All right, so when we factor difference of squares, the very first thing you have to make sure you do is that you can identify what a perfect square is. 1, 4, 9, 1 doesn't really matter, obviously. 4, 9, 16, 25, 36, 49, 64, that whole list of perfect squares up there. Also, it's a difference of squares, which means the two perfect squares have to be, what does difference mean?
Like
Subtracted, right? So that little note up there, the sum of squares is always prime, unless of course they have a GCF in them, but we're not even to that point yet. Okay, so that's something that we need to remember. This is one that tricks people all the time. If I have two perfect squares that are being added together, I cannot factor that. I can only factor two perfect squares that are being subtracted. And the little pattern is up on the board. It says x squared minus y squared. And the way that we factor that is in two parentheses. We take the square root of the first term. So the square root of x squared is just x. And then we take the square root of the second term. The square root of y squared is just y. And then as far as my signs go, it's going to be 1 plus and 1 minus. It doesn't matter which parenthesis you put them in, just as long as you have one of each. Everybody ready? Okay, so again, we're looking for two perfect squares that are being subtracted to be able to factor them. So we'll start with number 1. Good now? We're good? Okay. Keep in mind that when we factor, the very first thing we're always looking towards a GCF. Sometimes they will give us numbers that are perfect squares that have a GCF in them, or they'll give us numbers that are not perfect squares and they have a GCF, which will turn them into perfect squares, but we'll get to that point in a few minutes. So I'm looking at x squared minus 25. Do I have a GCF? No. So when we factor two terms, the only way we can factor them is if they have a GCF, which we said these do not. If they are both perfect squares and being subtracted, or both perfect cubes, which we're not to yet, so we're not even going to look at that one. Are x squared and 25 both perfect squares that are being subtracted? Yes. With your variables, in order for it to be a perfect square, the exponent has to be even. As long as the exponent is even, you can split it into two equal parts, okay? So what we're going to do then is we're going to take, maybe, and we're going to set up two parentheses. If I can get my pen to work, there we go. And in the front of the parenthesis, we're going to put the square root of the first term. The first term is x squared. What is the square root of x squared? How do I split that into two equal parts? Just x and x, so that goes in the front. Oh, come on. Oh, good grief. Let me check my battery, sorry. It's not wanting to work. There we go. And then in the back of the parentheses, what is the square root of 25? 5. So we put 5 in the back of the parentheses. And then for the pattern, as long as I have one of each sign, it doesn't matter which one goes first. You're going to have 1 plus and 1 minus. And then the only other thing you would try to do is to see if you can continue to factor. Inside of each parenthesis, do I still have perfect squares? I don't, do I? So that tells me that I am finished factoring. And I leave my answer just like that. Does everybody kind of remember difference of squares? All right, let's go with number 2. Sorry. 9x squared minus 16. Do I have a GCF here? No. Are both my terms perfect squares and they're being subtracted? Yes. So let's set up our 2 parentheses. What is the square root of 9x squared? 3x, yep. Oh, come on. It's really driving me crazy. Okay. Sorry, that's so ugly. And then what is the square root of 16? 4. And then again, as far as my signs are concerned, it's one of each. And then you just want to check and make sure you don't still have perfect squares, which we do not, because 3x is not a perfect square. So I'm finished. It's just a matter of knowing your squares, splitting them apart, putting 1 plus 1 minus. Is everybody okay with that? All right. Try 3 real quick. Do I have a GCF? No. Are both of my terms perfect squares? Yes, but what's wrong? Why can't I not factor this? Because it's a plus. The only way you can factor it if it is a minus. That's the one where I said this gets people every time. The sum, adding 2 perfect squares together, is not factorable unless they have a GCF. These do not have a GCF. So what do we call it when we can't factor? Yep. All right, let's be careful with 4. First of all, if I look at it just from the beginning, 4 and 64 are both perfect squares, aren't they? However, what's the first thing we're supposed to look for? What do they have in common? A 4. So we're going to need to pull that 4 out first. If I divide 4x squared by 4, I'm left with x squared, okay? And if I divide 16 by 4, what am I left with? I meant 64. 16. Oops.
Why is 3 not x plus 6, x plus 6?
Because when you can't factor a sum of squares, so like let's take a look at that. If I had x plus 6 times x plus 6, because this is what a lot of people try to factor it as. Remember, we can always check ourselves by multiplying it back out. These middle terms here, those don't cancel. So that doesn't give me, does that make sense? And that's a good question because a lot of people see that and they always want to put x plus 6 and x plus 6. But that does not just give me x squared plus 36. It gives me x squared plus 12x plus 36. So just be careful with that. Now, with number 4, we pulled out the 4. We have in our parentheses the x squared minus 16. Are those both perfect squares still? Yes. So we can continue to factor. Don't lose the 4 that you pulled out in the beginning. Starting verses. Nope. So that means that we can continue to factor. Okay, that's right. No. One more time. So we keep the 4. We set up our 2 parentheses. The square root of x squared is x. The square root of 16 is 4. We do 1 plus. We do 1 minus. Do I still have perfect squares inside my parentheses? Yeah. One of them is. The 4 is. Is the x still a perfect square? No. Okay, so be very careful with that. The 4 is a perfect square. But because the variable is no longer a perfect square, I cannot continue. So we leave our answer just like that. Everybody okay there? All right, try 5, and then we're going to have to talk about 6 together. And these are the last two. 49x squared minus 100. Do I have a GCF? No. Are those numbers perfect squares? Yes. So we can continue to factor because they are being subtracted. What is the square root of 49x squared? 7x. Okay. What's the square root of 100? 10. And then we do 1 plus. We do 1 minus. Do I still have perfect squares? No. Everybody ready for 6? All right, so this one tricks people quite often. On the quiz or the test, this would be a question where people lose points all the time because they do not finish factoring it. Let's talk about that. The clue that I will probably have to factor more than once is the exponent up there. X to the 4th. If I split that into 2 equal parts, it's going to be x what? X squared, which is still a perfect square, okay? So let's start in the beginning. I'm going to split this up. X to the 4th split into 2 equal parts is x squared and x squared. What is the square root of 81? 9. And then with our signs, we put 1 plus and we put 1 minus. The problem here is I still have what? Perfect squares. I have an x squared and I have a 9. Don't factor too much. Which one of these cannot continue to factor? The x squared plus 9. So that one is going to come down. It is going to stay the same because it is a sum of squares which cannot be factored. However, this parenthesis right here, the x squared minus 9, they are both perfect squares. They are being subtracted, so I can continue to factor. So I'm going to set up 2 more parentheses. What's the square root of x squared? What's the square root of 9? And then with my signs, I do 1 of each. And that is completely factored. Okay. So a lot of the times on the test quiz, I get some people that leave it like this, which means you're going to lose points because it's not completely factored. And then I have people that factor too much. They break both of them down and they try to do this. That one's going to be completely wrong, okay, because you factor too much. Factoring not enough, I can give you partial credit because you at least started it the right way. But if you go too far, I'll have to count it wrong.